Hello viewers, in this video we are given that y equal to cube root of ax plus b all squared, and then we're asked to find the y, the x. So the first thing we do is to write out our question. We have that y equal to the cube root of ax plus b all raised to the power of 2. So because it is cube root, we can rewrite this equation this way: ax plus b all raised to the power of 2 times 1 over 3, because cube root is the same thing as raised to the power 1 over 3. So but if it were to be square root, if it were to be just square root, it would have been times 1 over 2. So this equation, from here we are going to have ax plus b all raised 2 times 1 here is 2, or let's say 2 times 1 over 3 will give us raised to the power of 2 over 3. And so while looking at this, we've established this is chain rule. So the first thing we do is we can say let if equal to ax plus b. So if we say that if is equal to, okay, let's call this equation 1, equation 2, equation 3. So if we say let if equal to ax plus b in equation 3, it means if f is equal to ax plus b, it means y will be equal to f raised to power 2 over 3. Okay, we can call this equation 4, and we call this equation 5. So we have been able to establish that. So the next is for us to differentiate f with respect to x in equation 4 and y with respect to f in equation 5. So from equation 4, the f over, that is differentiating f with respect to x, will give us a. That is, if we differentiate f here with respect to this equation, it will give us a. And from equation 5, we can say here from equation 4. So we have this. Then again from equation 5, if we differentiate y with respect to f, so we have dy over the f will be equal to, so if we are differentiating this, we are going to have 2 over 3 times f raised to power 2 over 3 minus 1. So this will give us 2 over 3 f. So let's find this. So this will be the same thing as saying 2 over 3 minus 1 over 1. Okay, we just find the reciprocal of that one so that it will make it easy for us to solve. So this will be equal to 2 all over 3 f. The LCM of 3 and 1 here is 3, so we have it to be 3 here. So 3 here dividing this 3 here will be 1. 3 dividing this 3 here will be 1. And then 1 times these 2 will give us 2 here. We have minus here, so we have minus. 1 into 3 will be 3. 3 times this 1 here will be 3. So this will now give us 2 over 3 f. 2 minus 3 is minus 1 all over 3. So this means that our dy over the f equal to 2 over 3 f raised to power minus 1 over 3. So we can now invoke our chain rule. Our chain rule will be dy over dx equal to df over dx times dy over df. So that is a chain rule. So if you look at the chain rule, you see f and then you have c dy dx. So this is the same thing as saying our dy over dx is a. So we have a here times our dy over df. This is the value. This is the value of our dy over df. So this will be 2 over 3 f raised to power minus 1 over 3. Okay. And so this is the same thing. If we now say a times this will be the same thing as saying, of course, we know that from indices, a raised to power minus 1 over 3 is the same thing as 1 over a raised to power 1 over 3. So we can say that f raised to power 1 minus 1 over 3 is the same thing as 1 over f raised to power 1 over 3. Yeah, it's the same thing. So if we agree that at this point that it is the same thing as this, a new equation will now become a times 2 all over 3 f raised to power 1 over 3. So this will be equal to a times 2 will give us 2a all over 3f raised to power 1 over 3. But we know that f equal to, remember this is what our f is equal to. So f is equal to ax plus b. Okay, so we now bring that value here so that we have that dy over dx will be equal to 2a over 3 into the value of our f. The value of our f is ax plus b, and this is raised to the power of 1 over 3. So viewers, we've been able to solve that question. We've gotten to the end of that question, and so that will be the value of our dy dx for that question. So we've applied chain rule in solving the question. So that is it. Thank you.